just to add.
Yeah.
You're like, that's a you problem.
Yeah. All right, there's the start. Okay, great. And then, so we're going to do some synthetic division. And so this turns out to be x minus 5 plus 6 over x plus 4. Good. Right here, this is your slant asymptote. So your slant asymptote is y equals x minus 5. This is our slant asymptote. It's that quotient portion of our division. And graphically, that would be the line 1x minus 5. So you start at negative 5 and go up 1 over 1, up 1 over 1. Nice little slanty line. Okay, so what about number 2? You want to use long division or synthetic division? We can use synthetic again, yeah.
Synthetic's nice.
So synthetic is nice. All right. So what goes on the outside here? Positive 3, the opposite of the bubble. Okay. And then along the top, we're going to have a 3, a negative 7, and a 0. Very good. Thank you very much. All right. So bring down the 3 and multiply. Combine. Multiply. Combine. And so we get 3x plus 2 plus 6 over x minus 3. What is our slant asymptote? Yeah, y equals 3x plus 2. It is the equation of a line, so it is important that you have it a full equation. A left side and a right side, an x and a y. It has to have an x and a y in order to graph it. So that's just sort of being a little bit nitpicky. Okay, let's look at 3 and 4 here. On number 3, again, it is over the top. We've got a degree higher, which means we can simplify using division. Can we use synthetic division? No, we cannot. So on this one, we have to use long division. So it's good to go back and remember. You could use the box method, yes. But you will get a remainder, which may or may not throw you off a little bit. But okay, let's see. So there's my setup. What times 3x give me 6x squared? 2x's. So then we have to distribute that 2x. So 2x times 3x is 6x's squared. And 2x times 2 is 4x. And then we need to subtract everything. 6x squared minus 6x squared is 0. 4x minus 4x is 0. Oh, that's kind of interesting. Okay. So we bring down the negative 11, yeah. And hey, yeah, that's our remainder. Because I can't do any more division. So then that would be plus negative 11 over 3x plus 2. All right, so there's our remainder over divisor. What is our slant asymptote there? Yeah, y equals 2x, yeah. You need to get in here? Yeah. Does it look weird? Yeah, I bet. All right. Number 4, same thing. I have to do some division because again, it's over the top. It's top heavy, heavier on top, higher degree. So I have x cubed plus 3x squared. What? I'm gonna have to fill in some zeros. I think 0x plus 0. We'll see. Maybe see what happens. All right, let's see. So x on top, and then we have to distribute to all 3 terms there. X times x squared is x cubed. X times 2x is 2x squared. And then x times negative 3 is negative 3x. And then we need to do what? Subtract everything. 0, 3x squared minus 2x squared. 1x squared. And 0 minus a negative 3x plus 3x. 0 minus a negative turns to plus, so plus 3x. And I can bring down the 0, I guess. All right, and then let's see, go back to the top here. What times, yeah, plus 1. So that would be 1x squared plus 2x. 1 times negative 3 is negative 3. And we're going to subtract everything. Whoops, a daisy. Alright, so that cancels out. 3x minus 2x is 1x. Good. And 0 minus a negative becomes plus 3. So that's our remainder. Yes, sir.
Wouldn't you be able for the equation we just did double bubble the
Oh,
because you can take out the x out of the numerator and get x times x plus 3 on the bottom. Double bubble it x plus 3 and x minus.
so on this one, yes, it does do that. I didn't even think about it. But yes, that one does happen to simplify by factoring. But yes, we did the longer way because we're really just practicing division again, polynomial division. That's okay. Good thinking. That yes, factoring is now. This is on all of these today on Delta Math. You're gonna have to do the math because they're not gonna factor. Yeah. All right. So turn the page. We're gonna do some more here. Oh, so I changed all the problems. So please cross out what's there. So we can talk about what's happening here. And again, we're not going to focus too much on graphing because we have calculators. We can graph these on our calculators. That's no problem. Negative 4 over 2x plus 5. So we can graph these and have a looky look at what they look like pretty easily. But to get started, this denominator tells me a lot of information. Denominator domain. This denominator, 2x plus 5, is not allowed to equal 0. Denominators cannot equal 0. And if we solve that, that's telling us a couple of different things. X cannot be 5 over 2, which, yes, is 2.5 or 2.5. All right, that is domain. Right off the bat, x cannot equal 2.5. It also happens to give me that vertical asymptote. Sorry, negative. It should be negative 2.5. Why is it negative? Yeah, you got to subtract the 5. Thank you. So there's a vertical asymptote at negative 2.5. And that's what that asymptote means. We're not allowed to equal it. It's like a break in our graph. We're not allowed to equal it. And so that denominator gives us a couple of things. A horizontal asymptote. Which case is this for the horizontal asymptote? Yeah, the numerator degree is less than the denominator, which means we can't do any division. So how many times does the denominator go into the numerator? 0 times. So that is our horizontal asymptote, y equals 0. And so we have this horizontal asymptote right here. And that also means y cannot equal 0. Yeah. And we can see that sort of reflected here in our graph as well. It's not showing too good there. There we go. So you can see we have this horizontal asymptote right there. We're going to get close to it, but not touch exactly. Now, we have a couple of other things here. There's no holes in this. There's no slant asymptote. And I want to find the intercepts. Where did the x-intercepts come from? Well, let me start here. How do you find a y-intercept? F of 0. Yeah, it's when we plug in a 0 for the x. So to find a y-intercept, we plug in a 0 for the x here. And so we can do that. So that's going to be negative 4 over 2 times 0 plus 5. And we would get negative 4 over 5. Good. Okay. So that's our y-intercept. 0, negative 4 over 5. Let's see. 0, negative 1, 2, 3. Oh, negative 4/5. That's less than negative 1. So it's right there. There we go. There's our y-intercept. All right. For the y-intercept, we plug in a 0 for x. How do you find the x-intercept? Yeah. Oh, the x-intercept occurs when the y is 0. And so what we're doing is we're taking our equation, we're actually setting it equal to 0. Negative 4 over 2x plus 5. How would you solve that? Let me do this. What if I made it 0 over 1? Cross multiply. Yeah, which I think is the same as multiply. What happens when I take 0 and multiply it to 2x plus 5? It's 0. And then if I did 1 times negative 4, that's just negative 4. Can 0 equal negative 4? No, it can't. Yeah, there is none here in this particular case. So what happens, which I didn't talk about yesterday, and I should have, I admit, that when we're finding the x-intercepts, that's when our y is 0. Whatever the denominator is, it multiplies to the 0 and disappears. Which is why I said the x-intercepts come from the numerator. Okay? So let's talk about that a little bit more. Let's keep going. Well, we've graphed this. This is, there we go. There's your graph. Okay. So again, our job is figuring all these little pieces today. That's what we're doing. So number 6 here is f of x equals negative 3x plus 3 over x squared minus 1. What do you want to do? I could graph it. Yeah, I can absolutely graph it. But it's not going to tell me all of these things. You know what I mean? X squared minus 1.
Figure out the domain.
We can figure out the domain. So here's the graph. That's what it looks like. All right. Should we do division with this?
You can factor it out.
We can double bubble. We can factor. Yeah. This one, we can factor. That was always a good recommendation. Factor first. What can we do in the numerator? Yeah, there's a greatest common factor there, GCF. So I take out the negative 3. If there's ever a negative, take out the negative. All right, if I take out the negative 3, what's left behind? X minus 1. Beautiful. And then in the denominator, what do we have? Double bubble. All right. X plus 1, X minus 1. Beautiful. Yeah, okay. So great. We can see a lot of things here. First of all, we notice right here, circle those matching bubbles. What does that give us? A hole at x equals 1. All right, we have a hole at x equals positive 1. Now, I know that that's x value is 1. How do we figure out the corresponding y value of that hole? So does this simplify?
The 3 over x plus 1.
Yeah, negative 3 over the x plus 1. You'll notice I didn't write an equal sign. I'm doing an arrow.
Negative 3 divided by 2.
Yeah, so this would be, let's see. So if we plug in that 1 in place of the x, we'd have negative 3 over 1 plus 1. So negative 3 over 2. Okay. So yeah, you're going to plug in that where the hole occurs, and you plug it right into that simplified function. All right, so that's the hole. That is part of domain that I need to take care of. Where else? What does this bubble tell me?
The domain.
Yeah, that's part of domain as well. So that denominator, anything in the denominator, x is not allowed to equal. So yeah, so that's part of domain. X is not allowed to equal negative 1, and it's also not allowed to equal the positive 1. That's part of the whole. Yeah, anything in the denominator. So both of those make up.
Oh, like even before I can't see.
Yeah. So everything, all of that, if you were to solve, you get plus or minus 1. Yeah. So anything in the denominator, domain denominator.
And that can be the number.
Oh, yeah. So this also gives us the vertical asymptote. So we have a vertical asymptote at x equals negative 1. Now let's see if we see that on our graph here. So yes, there's my vertical asymptote right there at -1. But what's going on with the hole? Can I see the hole? No, I can't really see the hole because it's just, it's too tiny. But if I plug in 1, so trace and hit 1, you can see that there's nothing there. It's undefined. Okay. If I move Tinkerbell just a skosh, you can see there, right next to that, Tinkerbell would be where the hole is. At 1, -3, -1/2, 1.5. All right. Let's see. What case is this for the horizontal asymptote? What case is this? The numerator is less than the denominator. Yeah, this is a power of 1. So again, it's y equals 0. We can't do any division here. So we get a horizontal asymptote at y equals 0. The denominator is larger. Also, yes. Now, the range, where y is not allowed to equal 0, but also, because there's this hole at 1, -1.5, there's a hole right here. And I have my vertical asymptote at -1. All right, and my horizontal asymptote was at y equals 0. My graph comes through and makes that little L shape here at the hole. Is there a y value there? No. So that is also, it can't equal -3/2. So part of the hole there, that y value is also excluded from the range. Does that make sense to you? Okay. So there's the other side of the curve right here. What are we missing? We're missing y-intercept. How do you find a y-intercept? Plug in 1. All right, so f of 0, where do you want to plug it in? At the beginning or the end? Doesn't matter. I love that answer. It doesn't matter. These are all equivalent, sort of. So yeah, I can totally do the end here. So -3, 0 plus 1, we get -3. So we have a y-intercept of 0, -3. And, oh, look at, oh, I almost went through it. It's right there. 0, So then, how do we find the x-intercept? It's equal, our function, is equal to 0. So to find the x-intercept, we want to say, hey, 0 equals my function, and I can use any of them, but I certainly think the simplified function is the way to go, right? Yeah. -3 over x plus 1. What's going to happen? It cross, yeah, we can put it over 1, and we can cross multiply. Does 0 equal -3? No, so there is none here. There is no x-intercept. There's no slant asymptote. Okay. Questions so far? All right. Let's look at another one of those. No.
One more.
No, I said let's look at another one. I didn't say one more. Okay. So here again, we have, again, similar problem to what you're going to see. I wanted to give you some Delta Math type of questions. All right, so the difference is Delta Math was written by a math teacher. I want you to know this, okay? With the specific goal of teaching you what you need to know for calculus. All right? The factoring that is required here is the factoring that you need to know how to do on calculus, all right, for calculus, all right? And you see here, this was a much harder factoring problem. It's not actually that hard to calculate. Okay. So, what can we do to start up here and -2? Yeah, plug -2. We got GCF here, so take out a -2, and what's left behind? X minus 1, bueno. And then in the denominator, double bubble. Excellent. X minus 1 and x minus 2. Beautiful. All right. And what do we have there? A whole, yeah, good. We see a common factor there, so we know that gives us a whole at x equals 1. And this simplifies, right? Like we can clean that up a little bit. So it simplifies to negative 2 over x minus 2.
Yeah.
All right. So then I know that my whole has the x value of 1. How do we figure out the y value? Yeah, you plug it into the simplified function. So that'd be negative 2 over 1 minus 2, which could give me negative 2 over negative 1, which gives me positive 2. All right. So my whole is at 1, 2. I guess I'll graph that. 1, 2. There's a little hole right there. What else do I know from the denominator? Domain. Denominator, domain. Good. So this is part of the domain. And so that says x is not allowed to equal positive 2. That also is the vertical asymptote. So we've got a whole and a vertical asymptote and domain, all in like one denominator there. It's crazy. So x is not allowed to equal 2. It's not allowed to equal 1. Yes?
So why isn't the vertical asymptote 1?
Because it's a whole.
Okay.
Okay? So it cannot be both. All right? And because we have that common factor, it's taken out. Right? So it's a whole before it's a vertical asymptote. Okay? But that's an interesting question. I'm going to hold on to that. So one of them, that 2 there, is a vertical asymptote at x equals 2. So I'm going to draw that in. And I guess I want to know what is the horizontal asymptote, because that's really helpful. What case are we in for this one? Numerator is less than the denominator. This is x to the first power, which means y equals 0 every single time. And that is part of the range. Yes, y can't equal 0. So we've got this horizontal asymptote. What else is y not going to be? Yeah, it's because of the hole. We have a hole right there that's not going to have a y value associated. So y can't be 0 and y cannot be 2. All right, cool. What else should we know here? Oh, I didn't write down my vertical asymptote. My vertical asymptote was x equals 2. I wrote it right there.
You do the y.
Y-intercept? Okay, y-intercept I did in maroon. Okay. So my y-intercept, let's see. Y-intercept we get by plugging in a 0. All right, so f of 0. Do you want to plug it in at the beginning or the end? I would plug it in. Negative 2 over 0 minus 2. What do we get? Positive 1. Yes, the y-intercept is 0, 1. That's right there, 0, 1. Wait, what was that? 1. Yeah. All right. So I can, there's part of my curve right there. Let's see, other thing I need is the x-intercept. I did that in lime green. All right, lime green. How do we find an x-intercept? Set it all equal to 0. That's when the y is actually equal to 0. So we have 0 equals negative 2 over x minus 2. What's going to happen? Yeah, it's not going to be true. It can't ever, not ever cross multiply. We get something false. So there is no x-intercept here. All right. So that should be the other side down there. All right. How do you feel about that? Is that okay? Feeling pretty good with those? Okay. So I have 2 more that are a little more complicated. Okay, a little more complicated. We have negative 3x squared minus 12x over 2x squared. We get. Before I get to horizontal asymptote, though, what can we do? GCF. All right, GCF. So I have, what can I take out of there? Yeah, negative 3x And then if I take out a negative 3x, I am left with x plus 4, right? And then in the denominator, I'm going to write this out a little differently. I'm going to write it as 2. And I write it as times x times x. All right. That's the same thing, right? These are complicated. I want to graph this because even I am not quite sure. And I don't have a cheat sheet.
Well, it's because you made your own.
Okay. So I'm going to look at this and kind of help me figure out what's going to go on here. What do you think is going to happen? Do we have a hole? All right, let's look. Okay. Well, this is kind of interesting looking. All right, you see that? Okay, let's see what happens here. We do actually have a common factor. We have a common factor right here. There's an x on top and an x on bottom. Okay. Which means that we would perhaps have a hole at x equals 0. But wait a minute. Here I have another factor. So what does this factor do? So on the others, one of them was a hole and one of them was a vertical asymptote, right? Okay. So I've got my hole here, but then I have this extra factor that would be the vertical asymptote at x equals 0. X cannot equal 0. So just like before, we have a hole and a vertical asymptote. Well, wait a minute. Can I have a hole at the same location as a vertical asymptote? That doesn't work, okay? And so you can see by the graph, okay. I know it's funny. I can imagine what's funny, but that's okay. By the graph here, they can't be both. All right. Not when they match. The vertical asymptote trumps. All right. So they can't be both. So it turns out that that vertical asymptote trumps our hole in this case. So we don't have a hole, even though our function does simplify. It simplifies to negative 3 times the quantity x plus 4 over 2x. All right, and that's why, because there's still an x on the bottom, that is the vertical asymptote right there.
So it just cancels out.
Yeah. And so we have that vertical asymptote at x equals 0. That's because that's the x that's left in the denominator. All right, that reduces away first. And so now we're left with that vertical asymptote at x equals 0, which means x is not allowed to equal 0. The hole disappears itself. What case is this for the horizontal asymptote? Equal, yeah. The degree of the top is equal to the degree of the bottom. The numerator is equal to the denominator. So how do we figure out our... Yeah, it's just dividing those leading terms. Negative 3x squared over 2x squared cleans up. Those x squareds reduce, and we just get the negative 3 over 2. So we just have to reduce those leading terms. So we have a horizontal asymptote of y equals negative 3/2. So that's a negative 1.5 right there. Which means our range y cannot equal negative 3/2. All right, let's see. What else can we figure out here? Y-intercept. What's our y-intercept going to be? Y-intercept, we're going to plug in 0 for x. Do you want to plug it in at the beginning or the end? Yeah, either place would work. So if we plug it in at the end, negative 3 times 0 plus 4 over 2 times 0. Oh, what do we get there? Undefined. Yeah, it is undefined. We can't have a 0 in the denominator, so undefined. When the 0 is under, it's undefined. Good, very good. All right, let's see. What is the x-intercept? How do we find the x-intercept? All right, the x-intercept, we set it equal to 0, so we have 0 equals, again, I'm going to go with my simplified function here, negative 3 times the quantity x plus 4 over 2 times x, and we would cross multiply there, so 2x times 0 is just 0. So we get 0 equals negative 3 times the quantity x plus 4. How do you solve that? You can distribute if you wanted to.
Well, and we know it's not there.
We can actually solve for x here. Divide by negative 3. Okay, I can definitely divide everything by negative 3. So that would give me 0 equals x plus 4. So move the 4, we get negative 4. So the x-intercept is negative 4, 0. So that came right there. That is our x-intercept right there at that bubble on top. All right. So we have the x-intercept at negative 4, 0 right there. Hey, look at that. I can trace and type in, whoops, negative 4. Oh, no, that was a positive 4. Negative 4. There we go. There it is. There's my x-intercept right there. Negative 4, 0. Okay. How do you feel about that? Tired. It's a lot. There's a lot here. It's a lot to do. Yeah. Do you need another one of those, or do you think you can see? All right. I want to say, when in doubt, graph it out. So that calculator can help you determine what happens here when you have the hole and a vertical asymptote.
We have delta mass.
You have a delta mass.